talking about the Cassini-Huygens Space Mission Part 2. So this video is the Part 2 in a series. Well, in the Part 1, I explained about how the Cassini-Huygens spacecraft worked and why it was developed. In this video, I'll be talking about the history of the primary mission of the Cassini-Huygens spacecraft. So the Cassini-Huygens spacecraft was a spacecraft sent to observe Saturn and its moons. The Cassini-Huygens spacecraft consisted of the Cassini spacecraft and the Huygens space probe. And the Cassini-Huygens spacecraft was a collaboration with NASA, the ESA, the European Space Agency, and the ISA, which is the Italian Space Agency. Many more countries had also participated in it, but NASA spent the majority of the work on the Cassini spacecraft, and the ESA mainly focused on the Huygens space probe. So, the Cassini-Huygens space mission was launched on October 15, 1997, and to be more precise, it was launched at 4:43 a.m. Then, on April 25, 1998, the Cassini-Huygens spacecraft reached Venus. Now, this is pretty weird because the Cassini-Huygens spacecraft was going to Saturn, not Venus. So, why would it be going to Venus? Well, the reason why was that it was going to go and just going to fly past Venus, and by doing this it would give it a boost, which is called a gravity assist, using Venus's gravity as a boost on its journey to Saturn. And it took two flybys, the second one on June 24 of 1999. Then on August 17, 1999, it flew past the Earth and the Moon. On December 1999 to April 2000, it flew through the asteroid belt, and finally, on December 29, 2000, the Cassini spacecraft passed Mars and got to Jupiter. At Jupiter, the Galileo spacecraft was currently doing observations there. So the Cassini spacecraft, in a sense, worked with the Galileo spacecraft to do a little bit of observations on Jupiter. Then, on June 1, 2004, the Cassini spacecraft, let's say, was almost at Saturn, but it discovered two new moons of Saturn, Meton and Pallene. Then, it observed Phoebe. And Phoebe was this moon of Saturn that was very cratered. It had craters all over it. And the Cassini-Huygens spacecraft supported the theory that there was ice underneath Phoebe's surface. And then, on July 1, 2004, at 9:12 p.m., the Cassini spacecraft became the first spacecraft to ever orbit Saturn. Okay, so now it's fun fact time. And the fun fact for now is, did you know that over 5,000 people worked on the Cassini-Huygens space mission? So right after the Cassini-Huygens spacecraft got into orbit of Saturn, the mission scientists were like, you know what, we're going to go to Titan. So the Cassini spacecraft went straight for Titan. And Titan is the largest moon of Saturn. And the Cassini spacecraft took a lot of photos of Titan during its July 2 flyby of Titan. And it took two flybys, one on July 2, 2004, and the other on October 26, 2004. Then, on December 25, 2004, Christmas Day of 2004, the Cassini spacecraft detached the Huygens space probe. So that was the main purpose of the Huygens space probe, to land on Titan and take a lot of photos of Titan. Then, on December 30, 2004, the Cassini spacecraft visited Ayapuris, one of Saturn's moons. Now, Ayapuris had this strange equatorial ridge, basically a ridge around the equator, and scientists had always been mystified on how it had formed. Now, this equatorial ridge kind of made the Iapetus look like a walnut. So in this image, it's Iapetus, and you can see this ridge over here. It makes it look like a walnut. And the Cassini spacecraft found some evidence to support a theory on how this equatorial ridge formed. And the theory says that a small celestial object, probably a meteoroid, came and hit Iapetus. When it hit Iapetus, it split into these small particles. Then, because of Iapetus's gravity, they came and fell towards Iapetus. So that's how the equatorial ridge formed. And then, on January 13, 2005, the Huygens spacecraft finally landed on Titan, and it took some really interesting photos. So over here on the left, you can see a photo that it took once it had already landed on Titan. And these rocks, they're very smoothly shaped. That is evidence that some liquid had once flowed over them. Because that is what happens when a liquid flows over a rock. And that is called erosion. And in the image on the right, you can see these lines over here. And they kind of look like rivers once flowed through them. Like rivers that dried up. Okay, so on February 17, 2005, the Cassini spacecraft visited Enceladus. Enceladus was discovered by William Herschel over here. And on March 17, 2005, an important discovery was made on Enceladus. And that was, Enceladus had an atmosphere. Now, not many moons in the solar system have an atmosphere. Titan had an atmosphere, and Ganymede, the largest moon of Jupiter, had also had an atmosphere, but not many moons have an atmosphere, so it was very surprising. And Enceladus, and what's more, Enceladus' atmosphere was made up out of water vapor, which meant that there was some water somewhere in Enceladus. Okay, so moving on. The Earth's atmosphere consists of 78% nitrogen, 21% oxygen, 0.96% argon, and 0.04% carbon dioxide. The atmosphere of Titan consists of 97% nitrogen, 2.1% methane, and 0.09% other gases. And in April 16, 2005, the Cassini spacecraft discovered that these other gases mainly consist of hydrocarbons. And hydrocarbons are basically molecules that have hydrogen and carbon atoms. So ethane is one example of a hydrocarbon, and propane is another example of a hydrocarbon. So now let's talk about the rings of Saturn. So the rings are basically based on the alphabet from A to G. So there's the A ring, the B ring, the C ring, the D ring, the E ring, the F ring, and the G ring. However, it's not like the A ring is the closest to Saturn and the G ring is the farthest from Saturn, or the G ring is the closest to Saturn and the A ring is the farthest from Saturn. Rather, it's based on the time of discovery. So the A ring was the first to be discovered and the G ring was the last to be discovered. So the D ring is located over here, it's the closest to Saturn. Then we have the C ring, the B ring, and between the B ring and the A ring we have the Cassini division, then we have the A ring, then between the A ring and the F ring we have the Encke division, and then we have the F ring, the G ring, and the E ring. The E ring is the outermost ring. And the E ring in my example kind of looks like an orange line, but it's actually blue, and it's much, much longer. And the G ring is also blue. Okay, so on May 1, 2005, the Cassini spacecraft discovered a new moon called Daphnis. And Daphnis was located inside the A ring in a gap called the Keeler Gap. Then, on July 14, 2005, the Cassini spacecraft flew by Enceladus. On September 7, 2005, it flew by Titan. And on September 25, 2005, it analyzed a new moon called Hyperion. So Hyperion was this moon of Saturn that kind of resembled a sponge. It had a lot of holes around it, just like a sponge, and it was porous, just like a sponge. Okay, so on November 27, 2005, the Cassini spacecraft flew by Enceladus again, and it discovered something very shocking. That was, there was this plume of water gushing out of the south pole of Enceladus. And according to the evidence from the Cassini spacecraft, this water was coming from these tiger stripes, these blue lines over here. And this plume is called cryovolcanism. And cryovolcanism is basically when water spurts out, water and ice particles and other organic molecules spurts out of a volcano instead of lava or molten rock. So what's more, the material coming out from the plumes in the south pole of Enceladus was actually the material that made up the E ring. And the E ring is very long, so it's very, very surprising. So on July 1, 2006, the Cassini spacecraft explored Titan, and it discovered something very surprising. There was these lakes, methane lakes on Titan, not water lakes, but methane lakes. And the Hubble Space Telescope in 1994 had already discovered this, but it was not very certain. And the Cassini spacecraft kind of saw something in 2005, but it was not very certain that it was lakes. It was confirmed in 2007 that there was actually methane lakes on Titan, and they can be found in the North Pole and the South Pole of Titan. Okay, so on September 14, 2006, the Cassini spacecraft visited the Greens of Saturn. And what it discovered was that there was this bright arc. You can see this bright arc over here in the G. And this bright arc is what is giving a clue on how the G-ring is formed. So basically, these micrometeoroids, or basically dust particles, come and hit the bright arc, and inside the bright arc is this moonlight, and the micrometeoroids will get attached to it, and plasma from Saturn's magnetic field, which is just basically electrons, will come and push them out and that forms the G. Okay, so that was the primary mission from 2004 to 2008. That's a brief description of the primary mission. Because the Cassini spacecraft was still working by the end of the primary mission, or the official mission, then they added an extension called the Equinox mission. But it was still working. So they added another extension, the Solstice mission, from 2010 to 2017. So I'll be talking about the Equinox and Solstice missions in a part 3 for this video. So thank you for watching. I hope you enjoyed this video, and you can watch my Mars Pathfinder video over here and my Cassini-Huygens Spacecraft Part 1 video over here. And make sure you subscribe and stay tuned.